need to collect user input during tool execution without derailing your entire workflow. You'll see how FastMCP's elicitation system lets servers pause mid-operation, prompt for structured input, and resume seamlessly, all while handling schema conversion and type safety automatically. We'll implement a handler that captures user responses and returns them in the exact format the server expects, with zero manual JSON wrangling. From FastMCP Import Client. From FastMCP Client Elicitation, import elicit result. Async def elicitation handler, message, SDR response type params context. Hash present the message to the user and collect input. User input equals input, F message. Hash create response using the provided data class type. Hash FastMCP converted the JSON schema to this Python type for you. Response data equals response type. Value equals user input. Hash you can return data directly, FastMCP will implicitly accept the elicitation. Return response data. Hash or explicitly return an elicit result for more control. Hash return elicit result. Action equals accept. Content equals response data. Client equals client. My MCP server, Pi. Elicitation, handler equals elicitation handler. This demonstrates the interactive input pattern for dynamic workflows. The concept enables servers to pause execution and request structured user input when needed, rather than requiring all parameters up front. What makes this distinctive is the bidirectional communication flow, where the server initiates requests, but the client controls the response handling. The pattern works through a callback-based inversion of control. When the server encounters missing or ambiguous parameters, it triggers an elicitation event that routes to your handler function. The framework automatically bridges the gap between raw JSON schemas and Python types, letting you focus on the interaction logic while maintaining type safety and validation. This approach solves the problem of rigid, predefined workflows by enabling adaptive execution paths. It's particularly valuable for tools with variable requirements, like file operations needing path confirmation or analysis tools requiring runtime parameters. The trade-off is added complexity in state management, but the abstraction layer keeps this manageable for most use cases. Let's break it down. From FastMCP Import Client. From FastMCP Client Elicitation, import elicit result. Imports client for connecting to FastMCP servers and elicit result for structured user interaction responses. These are the core components for building interactive AI tools that require human input during execution. Async def elicitation handler, message, SDR response type params context. Hash present the message to the user and collect input. User input equals input, F message. This is the elicitation handler, FastMCP's required callback for interactive input. It presents the AI's prompt to the user and captures their response, bridging the gap between automated execution and human-in-the-loop decisions. The async signature enables integration with FastMCP's event loop while keeping the input operations simple and blocking. Hash create response using the provided data class type. Hash FastMCP converted the JSON schema to this Python type for you. Response data equals response type. Value equals user input. This instantiates the response object using the provided data class type. FastMCP auto-generated this Python class from your JSON schema, ensuring type safety and validation. The value field captures the user's raw input in a structured format. Hash you can return data directly, FastMCP will implicitly accept the elicitation. Return response data. FastMCP's implicit acceptance pattern. Returning the response data directly automatically resolves the elicitation, eliminating boilerplate. The framework infers the acceptance action from the return type, handling the protocol for you.
Hash or explicitly return an illicit result for more control. Hash return illicit result. Action equals accept. Content equals response data.
This demonstrates the explicit elicitation response pattern. The elicit result class gives you fine-grained control over the response flow, allowing you to specify actions like accept, reject, or defer with custom content. Use this when you need to handle complex validation or conditional logic before accepting user input.
Client equals client. My MCP server, Pi,
instantiates the FastMCP client, connecting to the local server defined in my MCP server, Pi. This is the entry point for all AI tool interactions, routing requests and managing state between your Python code and the MCP server. The client handles serialization, validation, and protocol compliance automatically. Elicitation handler pattern. This handler bridges human input with FastMCP's structured data flow, converting raw user responses into typed objects that conform to server-defined schemas. The response type parameter is always a data class generated from the server's JSON schema, even when requesting simple scalars like strings. Returning data directly implicitly accepts the elicitation, while elicit result gives explicit control over acceptance, decline, or cancellation.
The handler that knows nothing of schemas becomes the perfect translator between human chaos and machine order.